You know when someone looks totally calm on the outside, but you can just tell they are practically buzzing with energy on the inside? Well, believe it or not, our sun is doing exactly that right now. What happens when the sun's surface tells one story, a story of relative quiet, but its interior, measured by massive sound waves echoing through the star, is absolutely screaming? Welcome to the central scientific mystery of solar cycle 25. Today in this explainer, we're decoding a fascinating new 2026 paper from the BiSON network that uncovers a massive anomaly inside our sun. We are going to unpack exactly what the sun is hiding from us using some truly mind-bending seismic data. So, if you love peering beneath the surface of complex systems to figure out how they really tick, you're in the exact right place. Let's get into it. Now, to spot an anomaly, you gotta have a solid baseline. And in astrophysics, baselines take literally decades to build. What we're looking at here is a timeline of the sun's 11-year activity cycles, specifically those monitored by the Birmingham Solar-Oscillations Network, or BiSON. We start all the way back in 1987 with the beginning of cycle 22, move through cycle 23 in 96, cycle 24 in 2008, and finally arrive at our current epoch, the start of cycle 25 in 2020. That's nearly 40 years of continuous, high-precision observation. So how exactly do you get 4 decades of data from inside a giant ball of hot plasma? Through an incredible field called helioseismology. Just like geologists use earthquakes to map the Earth's interior, solar physicists literally listen to the sun's seismic heartbeat. They observe whole sun low angular degree sound waves, these are known scientifically as P modes, as they propagate through the star. By measuring how the frequencies of these trapped sound waves shift around, scientists can accurately diagnose the sun's internal health and its magnetic structure. Okay, and that brings us to the core conflict. On the left, we have our visible, traditional proxies, things we can easily see from Earth, like sunspot numbers and the 10.7 centimeter radio flux. These traditional measures point to a noticeably weaker cycle 25. But look over on the right. The seismic data, those internal sound waves we just talked about, they're indicating a surprisingly strong cycle 25. It's a massive, glaring mismatch. Let's dive right into this. Heading into 2020, those smoothed global activity proxies, again, your sunspot numbers and radio flux, represented here by the dashed and solid lines, tell a very specific story. Following the peak around 2014, these lines dip heavily into the solar minimum right before 2020. Basically, they're setting up what looks to be a relatively mild cycle 25 on the surface. But to figure out why the interior is going totally off script, we've got to break our detective work down into 3 distinct frequency clues. Let's kick things off with clue number 1, the low frequency shift. These low frequency sound waves, vibrating somewhere between 1860 and 2400 microhertz, are the deep divers. They penetrate the furthest into the sun's massive interior. Notice the blue data points here. For a long time, they tracked beautifully with the orange and green proxy lines. But look at what happens starting right around 2005, during the decline of cycle 23. The frequencies completely disconnect from the expected proxy lines. The internal activity establishes a higher base level that persists all the way into our current cycle 25. It's like the deep interior literally just stopped following the surface rules 20 years ago. Moving right along, we hit clue number 2, the mid-frequency drop. Now this band, vibrating between 2400 and 2920 microhertz, probes slightly shallower depths inside the sun. When we look at this mid-frequency data, we're basically tracking how sensitive these sound waves are to surface activity. And what researchers found is that the sensitivity gradients have systematically dropped lower over time. From cycle 23 into 24 and now into cycle 25, these mid-level sound waves are becoming less and less responsive to surface magnetism compared to the strong baseline set back in cycle 22. It's almost as if the middle layers of the sun are putting on noise-canceling headphones, just muting their reaction to what's happening above them. Which brings us to our third, and frankly, absolutely wildest piece of evidence. Clue number 3, the high-frequency surprise. Now, what's really interesting about this is how fast these waves vibrate. We're talking 2920 to 3450 microhertz, meaning they only penetrate a very shallow layer, about 1,000 kilometers below the surface. And just look at this massive, unexpected spike on the far right. The blue data points for cycle 25 drastically overshoot the expected dashed and solid proxy lines. According to this high-frequency seismic band, cycle 25 isn't weak at all. Internally, right near the surface, cycle 25 is just as strong as the massive cycle 22 was back in the late 80s. The shallow interior is, no joke, completely hyperactive. Seeing these two extremes side by side really hammers home the complete physical paradox we're dealing with here. On the left, you've got our deep diving low frequencies from earlier, which detached from the surface proxies and just leveled off. Then on the right, our shallow high frequencies are absolutely spiking off the charts. The deepest layers of the sun are operating on a completely different wavelength, literally and figuratively, compared to the hyperactive shallow layers right beneath the visible surface. Okay, let's piece this giant puzzle together. First, those deep monitoring low frequencies shifted unexpectedly starting way back in cycle 23. Second, the mid frequencies steadily lost their sensitivity over the last 3 cycles. And third, the shallow monitoring high frequencies are currently spiking massively in cycle 25. Because we know high frequencies monitor very shallow depths, while low frequencies reach much deeper, we can clearly trace exactly where the physical changes inside the sun are migrating. So what does this all mean? Well, the crucial point is captured perfectly by the researchers in this 2026 study. Tying our 3 frequency clues together, they conclude subsurface structural changes associated with successive 11-year cycles are becoming ever more progressively confined close to the surface. Basically, the physical engine of the solar cycle, the very magnetic heartbeat of our star, is physically migrating outward. Just think about that scale for a second. All of these incredible seismic anomalies prove that the physical changes driving our current solar cycle are now trapped in an incredibly shallow layer. They are confined within just 3,000 kilometers of the solar surface. Now, for a star that is 1.4 million kilometers wide, 3,000 kilometers is basically just the skin of the apple. The massive magnetic machinery of the sun is currently squeezed right up against its outer edge.
Let's see how this builds over the timeline. Over the last 40 years, the sun's internal engine has slowly pushed its way outward. Step 1. Back in cycle 22, the structural changes driving solar activity were deep-lying. Step 2. By cycles 23 and 24, those changes had migrated up to a maximum depth of about 3,000 kilometers. And now, step 3. In cycle 25, the most extreme internal activity is highly confined to just the top 1,000 kilometers.
This is a profound, massive shift in how our star operates, and it's all hidden right beneath a deceptively quiet surface, which leaves us with a huge question as we look ahead. As we finish out this cycle and head towards cycle 26, what in the world will the sun's seismic heartbeat reveal next, especially with the upcoming 22-year Hill cycle polarity flip, where the sun's entire magnetic field reverses? Will this intense shallow activity break through the surface, or is it going to migrate back down into the depths? The answer is out there, echoing through the plasma, just waiting for us to listen. Thanks for hanging out with me for this explainer, and keep your curiosity focused.